Jumping to the class today, as I told you, today we are going to talk about the maximum power transfer theory. Uh, Last class we have discussed about the Thevenin's theorem, Norton theorem, and Thevenin's circuit with dependent source. Thevenin circuit with dependent source or Norton circuit with dependent source are the same thing. If somebody asks you, okay, find the Norton circuit on the dependent source, then what you do, you find the Thevenin circuit first, and then you convert or transfer into Norton circuit. Because Thevenin and Norton, last class I told you, they are like voltage source and current source. These two brothers are equivalent. One brother is voltage source, one brother is current source. And a voltage source transformation, you know that how to do. Exactly, the Thevenin circuit can be transferred into Norton circuit according to the source transformation theorem. That is R Thevenin equal to R Norton. Remember, R is equal to RP. Like that way,
Yes.
then the other way. Then you can also, any question comes and tell you, find the Norton dependent source problem, find the Norton equivalent. Then what do? You find the Thevenin equivalent. You know how to do. And then you can easily convert into Norton equivalent. So it's not a problem. Both you can find from there. Now, today we are talking about maximum power transfer theory. This is one of the application of Thevenin's theorem, remember. So that one I'll show you later. But first we need to understand what does it mean? It means, look at it. If there is a source and this source is connected to the load, okay, this is the source and this connected to the load. Let's say the source is Vs and the source resistance is Rs. The load is connected here with RL. This is your load, this is your source. For example, this Vs, this is your power supply side and this is our consumption side. This is Vs, this is your, let's say, Ghorashal, and this is your Dhaka city. Ghorashal, what they do in Ghorashal? Ghorashal is in America, right? Have you heard the name?
No, sir, in Bangladesh.
In Bangladesh. What is famous for? What they do over there actually in Ghorashal? Do you have any idea? No, you never heard what is happening there or what is famous for? Okay.
They produce electricity.
Good, excellent, beautiful. So there's a power plant in Ghorashal, the biggest one of the big power plant in Ghorashal in Bangladesh. They use the electricity, they produce the electricity. And then through the transmission line, we are getting the electricity in Dhaka city, for example. So from there, if you produce, as I said, they produce the power. So that power you are supplying to the city, Dhaka city, and we are getting the power at Dhaka city. Our RL is the load we are getting. Like a load is the, and transmission line is the RS. Through the transmission line, the power comes from there to here, for example. So this is the transmission line resistance, and you know how to find it because the first class I told you, lumped resistance, distributed resistance along transmission line, you know, per 1,000 feet, how much ohm. We have a AWG, you know that AWG chart there, American wire gauge, from their resistance you can calculate, like sort of things you can imagine. So at the load RL, we are Dhaka city having this RL as a load. Load means your light, fan, air condition, whatever you are going to on and off. So your load is changing. So whatever the power the source is giving us, due to the change of the load, the power consumption is changing. Because the power what they produce is a fixed power. It is produced, 100 megawatt power is produced, let's say. So this power is coming to the output, that is RL we are consuming, and some powers are losing on the transmission line RS, that means on the resistance. And so let's say 100 watt, at 220 watt is lost, 80 watt we get, or like sort of different. So we are changing the load and we are getting the power at the output but we can see the losses are there. So we cannot get the maximum power at the output. So we are changing the load from what? From 0 ohm to infinity ohm. That is the case. So if you change from minimum to maximum load, then what will happen? You will get at the output different output load will be changing. So what will be the maximum, at what resistance value we are getting the maximum load? That is what we'll see. Is it all of you are thinking, sir, at infinity ohm if we put, then we can get maximum load at the output terminal? You can think like that. And if you put zero load, then the zero power we are getting at the output terminal. You are thinking like that because common sense you are thinking. But in reality, it is not the thing happened. There is something happened in reality. I mean, from the relationship, it is the relationship between the VS and the power at the output, the PRL, is completely non-linear, and that one is not linear, just a 0 to infinity and it will increase, not like that. So that relationship actually gives us the maximum power condition. That is what we are going to find today. Now you got the idea. Let's say now we can find out actually what is that relationship, that the power at the load terminal we are getting, at what condition we can get the maximum power at the load terminal. Okay, let us see here how to go for that. Now let's say that if this is the scenario happen, then what will happen if the power supply is connected with this thing? Then everybody understand that a current will flow through this circuit. So a current will flow through that, and that current we can say I. If this is I current, then we can say that the power consumed PRL by the load will be, can anyone tell me what will be the power consumed by the load? Load can be changed, as I said, from 0 ohm to infinity ohm maximum. So that one is the load, RL. So what will be the power consumed by the RL? PRL into
Sir, VAB into I.
oh no, AB
I
is
mean
not
V.
there.
Oh, okay.
What is given here is what are the things you know at this terminal. Actually, you know one thing. What is that? I. You know another thing. What is that? RL. Where you get VAB?
RL.
Okay, so you know these two parameters
Oh,
because
sir.
this current source, voltage source connected, a current is flowing through the load. Now we are going to find from this information what is power. P equal to what? You see the blue
I
circle,
square RL.
yellow circle. Yeah. What is that?
I square RL.
Absolutely correct. The you know this power equation will be very much straightforward. I square into RL. Now whatever RL value, this is the power equation in this case. This is the power consumed by the resistor. All of you get the point?
Yes, sir.
Okay,
Yes, sir.
straightforward. Yeah. Now if I ask you the PRL equal to, what is I equal to? From this circuit, if I say what is I equal to, anybody can tell me I equal to what from this circuit? Very straightforward. What is that? Vs divided by
RS plus RL.
any children didn't born yet, you bring from the road, he also can tell the answer that this is RS plus RS plus RL. Ohm's law, simply the voltage divided by the resistance. Resistance in this case is RS plus R. So Ohm's law say V by R equal to I. Hey, everybody got it?
Yes, sir.
Yes,
Yes,
sir.
sir.
Good. Now we can write over here in that case Vs over RS plus RL. RL whole square into RL. So this is the equation in terms of the parameters Vs, RS, RL we are getting for the power. This is the power equation we are having here. Now, if I ask you, okay, can you tell me when the load is 0 ohm, then what is the power? This is the minimum load. When the load is infinity ohm, then what is the power? Hey, load changing, this information is not new to you. This information I have given you last time. First time I have given you in the solar panel problem in the first class. Try to remember in what is the California, they tested a solar cell. There I have changed this load resistance. Try to remember. And when RL is 0, RL is infinity, is a short circuit, open circuit. Remember, after that, this RL change, I have given you another example where source transformation, that is voltage source, current source, for making them equivalent. Actually, I have done some test, and that characteristic curve we have drawn, they are also 0 to infinity. Now again, another example, another theory we are learning, the maximum power transfer. Also again, we are going to talk about 0 to infinity. Isn't it? The load changing from 0 to infinity is not new to you. You know that, right?
Yes, sir.
Okay. Now, if I say to you that if the load is minimum at RL equal to 0 ohm, can anybody tell me what will be the PRL? Tell me.
0, sir.
Absolutely great. Hey, rest of you short circuited. Got why it is 0? Do you understand? Okay, please let me know if anybody got any question. Okay, what your friend, why he said 0? Because he straight away put the value RL equal to 0 into the equation. And straight away he got the whole thing is becoming 0. And RL 0 here and RL 0 here, no problem, these two places. And he got the whole equation equal to 0. And that is what he said, it is 0 watt. Clear?
Yes, sir.
If it is clear, then you tell me the other end, that is if RL equal to infinity. If RL is infinity, then what will happen? Can you tell me now? Tell me, if it is infinity, I'm writing here again, at RL equal to infinity, then what happened? PRL at that time equal to what? What is your idea? All brain short circuited now.
Sir, infinity.
Okay, infinity. In that case, you are saying infinity. You are the 9 people there. Infinity. Okay, that means you are saying here PRL equal to VS by RS plus infinity whole square into infinity, right? That one you're saying infinity. But you have done the calculus and you know that this is not infinity here. It is rather infinity by infinity, right? Which is undefined. Got my point? Calculus, you did calculus? You
Yes,
heard,
sir.
you first time you heard, you know these things, that infinity by infinity is not defined value, it's an undefined value. So either you have to go to apply the L hospital rule, or you can go for some other sort of technique to find the answer. So it is not infinity, it is rather infinity by infinity, which is undefined. So this is not the case, the way you have to go. So what will be the answer then? If you find definite value, you're all right. But now if you want to find the definite value, what will be the definite value and how you find it? Okay, physically, I mean, practical, in reality, I'm just telling you, then I'll show you mathematically. Reality, if you see RL is infinity, hey, look, if RL is infinity, what is this? Circuit is
It
what?
means
Hey,
open circuit.
open circuit. If it is open circuit, the circuit is open. What will be I then?
0.
0. If I is 0, then what will be PRL?
0, sir.
Yeah, I is 0, I 0 square into RL. 0 square into RL equal to 0. So what we can see, 0 watt, if it is infinity, practically we can see actually in fact it will come as 0 watt as well. Hey, do you got it what I'm talking?
Yes, sir.
Yes, sir.
Okay, this is what we can see the reality. It should give you, it is giving you 0. But theoretically, you can see it is also giving you 0, not the undefined value. You have to find a defined value, definite value. And definite value will be 0. 0 is a definite value. This is all comes from calculus, trigonometry, mathematics. Mathematics is very important. And I think you lost everything. Next, come to control system, the trigonometry you required. But you forgot everything. How you answer there, how you understand, I don't know. Now look, you can do it in two ways. By applying the L'Hospital rule, dRL by dRL, upside and downside, you can get the first derivative and put the RL equal to infinity. Or you can divide the RL from here, and you can see this cut can come here as a V square. Okay, V square, and then what you call that, V square divided by, okay, I'm just going to do it here. Just going to do to the leftmost plates so that we have enough spaces. PRL will be equal to what? We can say Vs square divided by, if you take out RL from here, then all of you can understand this is RS by RL plus 1 whole square, and this is RL square, and that is into RL. Up to this, everybody understand, right? I'm
Yes, sir.
taking RL square. So RL square and RL cancel. This is RL remaining here. So RL remaining here. Now you put infinity here, then you can get Vs square, and it is infinity times, this is Rs by infinity plus 1 whole square, means you all understand this guard is a Vs square. This is infinity times, this is what, 0 plus 1 whole square, right? Because something divided by infinity is 0. Do you know this thing is 0? Do you know that?
Yes, sir.
Okay, good. So now again, Vs square divided by infinity is also equal to what? Equal to, this is infinity equal to 0, right? Are you confused?
No, sir.
Okay, so if it is 0, that means it is 0 watt, you can say also. Where is the problem? You can tell me if you have any question. Or if you apply the L'Hospital rule, then also you take the derivative up and down, then Vs square derivative, this is dRL by dRL, and this is ddRL of Rs square plus RL, Rs plus RL whole square. And take the derivative up and down, and you can find, after that you substitute the value of this is Vs square, and dRL is going to be 1, and it will be 2 Vs Rs plus RL. That's it, which is again something by infinity is 0. Then ultimately you are getting 0 if RL equal to infinity if you put. So this is how we can get, you understand, upside and downside, you do the first derivative, ddRL, and you get, after that you put RL equal to infinity. This is L'Hospital rule. Or upside also I have done. So either way you can get, this is 0 watt. So theoretically, mathematically, you can also see it is 0 watt. So we can write that when RL is infinity, it is 0 watt. So what can we see? That when the RL is 0, load is 0, it is, power is 0. When load is infinity, it is also 0. So at the minimum load and at the maximum load, both are giving you 0 watt. That means the power is 0 for both cases. That is what we can see here. Are you clear about up to this? Are you clear, or you have question? Please let me know. Okay with you?
Clear, sir.
Okay, if it is okay, then we can go with this. If I plot it, Let's say this is RL and this is PRL. Now, this is the starting point. What will be the RL value at this point? You don't understand the Cartesian graph. What is the RL value at this point?
0.
0. And RL value is over here, infinity. Infinity is far away. So RL is infinity there and RL is 0 here. So if RL is 0 here, the power is 0 at RL equal to 0, at power is 0 at RL equal to infinity. At both cases, the power is 0 here, the red point is the power, and over infinity, at the infinity also, the power is 0, so 0 watt. So both places, infinity is far away, that's why I'm just writing 0. So at RL equal to 0 ohm, at RL equal to infinity ohm, at both cases, the power is 0. Understand it?
Yes, sir.
Okay, now listen carefully. I know there are some good students. All are dark head. All are not dark head. I think there are some good students here can understand it. And those who cannot understand, I'm really very, very shocked. If I increase the resistance now, RL from 0 to, let's say, I can put 10 ohm, I can put 100 ohm, I can put 1000 ohm. That means I'm increasing the RL value in between 0 to infinity, 10 ohm, 100 ohm, 1000 ohm, like that way, a different value. If I put different value, then what will be PRL every time? What will be PRL value? PRL value will be what? Will be 0 also all the time. Is it 0 all the
No,
time?
no, sir.
No, not
No,
at
sir.
all. So if you put the value of RL for different value, then the PRL will be negative or positive. Hey Dax, what happened?
Positive.
Positive, sir.
All values here, if you put the RL, there is no negative sign here at all. And if you put the value, it will be all positive. You all understand this thing?
Yes, sir.
Okay.
Yes,
If
sir.
all the value positive, then you look, starting value 0 and ending value 0. And in between, when you put some other value like 10, 100, 1000, like sort of other values, then the curve will go upward direction or downward direction?
Upward,
Upward,
sir.
because all values are positive. So if you go for upward direction, then again here you come upward like this. That means there will be a peak here at which it will go, and then it will go down again, because the starting and ending both are 0 0. So in between all are positive, so you will get a positive hump, a positive peak in the curve like this, and that is the relationship of this RL and PRL, which is very much non-linear. This is what I'm talking, and the maximum power will be coming somewhere at the peak point. Hey Duck, do you understand it?
Yes, sir.
If yes, then tell me what should be the equation of this green line? Anybody? All are dumb. What happened? This green line should be PRL versus RL, right? YX. This is Y-axis. This is X-axis. Is it Y equal to MX? It's not a straight line.
No, sir.
So what should be the, it's a very much non-linear relationship. What is that relationship? So this should be PRL equal to what? Anyone? You cannot find the relationship between PRL and RL anywhere in the whiteboard. You cannot see. Can you see the any relationship, any equation which is relating the PRL and RL in our whiteboard here. I did not delete anything yet. Cannot. Okay. Look at it now. Hey, none of you, 9 pair of eye. You cannot miss it. This is what? What is this? Hello? Can you hear me?
PRL, sir.
Okay,
It's
RL, PRL. And this is what? This is RL and this is RL. So this is the equation which is giving you that relationship. What relationship? PRL versus RL. Got it now? Still confused,
Yes, sir.
right? You are all dumb. Is still confused or understand it now? Hey, what is
Got
it?
it.
You understand? No, still cannot get it, right? Are you? Can you please, what call it? Unmute your unmute your microphone. Otherwise, I cannot understand what you're talking, or you really listening to me, understanding me or not. Can you unmute? Yeah, and tell me the answer. Yes or no? Do you get it that this relationship is PRL and RL relationship is coming from this equation? Do you understand this?
Yes, sir.
All right, good. So I need to know about this, what you understanding. Otherwise, I'll all meaningless. Okay, now PRL, I can understand. Anybody look at the lecture video can understand. And if you don't understand, I think all ducks cannot understand as well. So please tell me. So this is the equation supposed to be, which is Vs squared divided by Rs plus RL whole square into RL. Now you can tell me, sir, what happened to the Vs and what happened to the Rs? The Vs and Rs, these two are fixed. These two are battery voltage, battery internal resistance, like that, or the transmission line resistance and the generator voltage is that one. So these two values are constant or fixed. Only the variable is RL, and because of RL, the power is changing. So the PRL and RL is changing actually. So I is substituted on, we are getting this thing. So you can see this is the actual relationship for this one. I'm going to write with the red pen, the PRL, and this is RL. So the red parameters are only the variable parameters, changing parameters, but green parameters are fixed. So only this is a, what do you call that? We can say this is the function of RL, right? The function of RL. Okay. So this is a function of RL here. Okay. So, or you can say here also the function of RL. So this is the relationship, and this is the equation of this green line actually, and which is very much, the relationship is what? This relationship is linear or non-linear? At least you can tell.
Non-linear, sir.
Yeah, that's why the curve is, the green curve is also a non-linear curve. It's not a straight line. It is a non-linear curve. And from this non-linear relationship, we have to find the peak value, this peak value. And at this peak, if you go, this is the one, this peak will be the P max, maximum power at this peak you are getting for certain value of RL. At what value of RL we are going to get this P max? This is a big issue now. That is what our target to determine. You all understand up to this?
Yes, sir.
Yes, sir.
Yes, sir.
Excellent. Now let's go with that curve. That curve Pmax determination, we are going to go for Pmax equal to what? That's the maximum power, and that's the maximum power theory we are going to go. Now, if you go with this, let's say this is the curve RL and this is PRL. Now, if the curve as a green curve we saw is coming like this, okay, it's going towards the 0. So equation you know already, I don't need to tell you the equation again. So this is the, okay, I'm just writing it, PRL equal to VS square RS plus RL whole square into RL. Into RL. Okay, so you understand it is into RL. So, okay, now our main target is to find the maximum peak at this point. What is the maximum peak? That's the part. Now, if you want to find the maximum peak, then from the maximum minimum formula you have studied in mathematics, at this point, you know that dy by dx equal to 0, the slope equal to 0. So in
0.
this, yeah, in this case, dPRL by DRL, okay, DRL will be also equal to 0. Equal to 0. So we can rewrite this thing here. Then how you can go for it? For example, you can write here dPRL by DRL equal to 0. If you write that, then you have to write the equation like this. It means DDRL, and that one is coming here as a VS square divided by RL, RS plus RL, S plus RL whole square into RL. So this is what you can say, equal to 0. That means you are substituting the value of D at the PRL. Now it is something like U by V formula. What we can say that this RL value, if you can put this RL on the top, RL here, and the same thing happened, right? Now I am going to write with this thing RL with the red pen, this RL with the red pen. This is only variable thing. Now if you see, VS square is a constant. So all of you look carefully. VS square is constant. So I can take the VS square out. So if we write VS square here, and take the VS square thing out like that, uh, will it be okay with you to understand? Is it okay?
Yes, sir.
Yes, sir.
Good. At least you understand it. So this is a constant and VS square. So I have taken it out, and VS square is a constant. So this constant cannot be equal to 0. So this is equal to, cannot be equal to 0. So then what? Then the rest of the part will be 0. So this rest of the part is nothing but this upside is U, the downside is V. So you have the differentiation idea, which is like, I'm just writing here, U by V, du by V. Do you know what is the equation coming here? Underneath is V square, V du minus U dV. Have you ever saw this thing in your life?
Yes, sir.
Okay, if you saw, we can apply this formula, then we can say that what? RS plus RL whole square, and this will be whole to the power 4, right? And V means RS plus RL whole square times d dt of RL, that means d drl of RL, minus then your V U, this is U, remember, this is U, yeah, URL, that is RL, right? Good. RL into d dt of, that means d drl of RS plus RL whole square. Yeah, equal to RL whole square. Okay, this is equal to 0. If this is the scenario, then what can we write here? We can write This thing will be multiply with 0, cross multiply with 0, cancel out, right?
Yeah.
Okay, then we are
Yes,
getting
sir.
here, yeah, we are getting here RL plus, this is RS plus RL, not RL, RS plus RL whole square. And this one is 1, right? This is 1. This is 1.
Yes, sir.
And 1 don't need to write, minus RL is there. And I think, can you do it for me? And then finally, what the conclusion you get? Can you, finally, our target is to find what is the value of RL. It means at what value of RL we are getting the maximum power. This is the RL value we are going to get. So what will be the RL at this? From this equation, we are going to get the RL. Can you tell me what is the value of RL from this equation? All of you do it and tell me. I hope that you're sitting down with a pen and pencil. Okay, with a pen and paper. So you do it and tell me what is the RL equal to. And those who are lazy duck, you just sleep. Let other friends do it and tell the answer. Then you copy paste and go back home. Don't need to do. Could you find it, anyone? Or you don't know how to do the derivative here?
Sir, RL equal to 1 by RS square.
No.
Sir,
Anyone? Yeah.
I got two equations, and one is RS equals to RL and RS equals to minus RL.
Okay. Because you got RL square equal to RS square, right?
Yes.
That is the right answer. And RL cannot be negative, so RL will be equal to RL. Negative and resistance cannot be negative.
Yes. Yes.
So RL will be equal to RS. So that is the answer. I don't want to solve this problem because this is very basic thing, and every student should know. I'm talking an engineering student. And if you want to claim yourself as an engineer in future, then you should have a very good background in mathematics. You are getting A in management, accounting, Bangladesh studies. You cannot claim yourself a good engineer, remember, I'm telling you. But if you get A in EEE 201, yes, you are. So mathematics is a very important thing. Everybody should know. You cannot say it will be considered for you because engineering is based on mathematics. And if you don't understand, you will be in real trouble, and be careful about it. So no problem, but you have to work more. I'm asking you in the class to do it. You try your best to find the answer. Then you can only learn. Even you are not good in mathematics, doesn't matter, but you need to give a go. You need to try. Just don't to sleep. Okay, now look, RL equal to RS. I'm not finding it. You all have to find it by yourself because one girl found it I think everybody can find it by yourself. And this will be coming, and from there you can conclude that RL will be equal to RS. So when RL is equal to RS, that means this one. That means at this point, because RL is 0 here, RL is infinity here, RL is, as I told you, 10, 100, 200, 3,000, 100, 10,000. RL different value. When RL equal to RS, RS is fixed. The internal resistance of the battery, it is fixed. When the RL is equal to that, or transmission line resistance, when RL is equal to RS, that time you get the maximum power. That is what the condition we found. So this is our condition. For what? This is the condition for maximum power transfer. This is main thing we have found from this relationship. This is the relationship we found for this condition, for maximum power transfer condition. So this is the maximum power condition. So when the RL will be equal to RS, then the maximum power will transfer from the input to the output. Let's go there, the circuit, look at it. When this RS and this RL you are changing, right? You are changing the value of RL 0 to infinity. When your RL will be somewhere, the value of RS is lying. Let's say 0 to infinity, in between. RS value must be in between 0 to infinity. When this value from 0, 1, 2, 3, 4, when it comes equal to RS, then and then you can get the maximum power at the output. This is the condition. These two cut, when RS and RL will be equal, then and then you can see maximum power will be transferred from the source to the load. All the children, you understand or not?
Yes, sir.
Good. Understand. Excellent. That's give me encouragement. Otherwise, okay, this is RS equal to RL, the maximum power you get. So this is the meaning of this thing. This is a condition we already found, that RL equal to RS. Now, if RL equal to RS, we get, but if I ask you, at this condition, we get the maximum power transfer from the source to the load. But what is that maximum power? What is the amount of that maximum power? Look at the graph. The maximum power will be here. Ting, ting, ting. This is the point for the maximum power. I think I can show you the orange color. So if you go with the orange color here, this is the maximum power. This is your P max. Right? This is your P max. So this P max equal to what? This P max equal to what? That is the maximum power. That is the amount of maximum power transferred to the load from the source. But we know the condition. Condition will be when the source resistance is equal to the load resistance. When the load resistance is equal to source resistance, then you can get the maximum power. Remember, this is very, very important. This is called impedance matching. Remember in your life, in future, in engineering, impedance matching, the word you will see even in telecommunication. You go for antenna design, or you go for some other place. How much power transferred to the antenna, maximum power, has impedance matching. What does it mean? This is the meaning. So this is called impedance matching also. The output impedance and input impedance. Impedance means, in this case, you can think is a resistance. So the resistance matching, input output load matching. Okay, this is why matching is required, because maximum power will be transferred. So this thing is a very important thing in electrical engineering, like Ohm's law, like that sort of thing. So everybody should try to understand this today's class and try to apply it in future. You can say you can apply it in that case. Otherwise, you don't understand, all go into vain. Now, what will be that maximum power? This is our question here. Can any one of you tell me what will be this maximum power? What will be the maximum power? Hey, you understand what is sleeping?
No, sir.
Okay, then tell me what will be the maximum power? How you do it? Okay, maximum power you can find because at maximum power, look at it. Can you see this equation, power equation, the black circle?
Yes, sir.
Okay. In
Yes,
this
sir.
power equation, if you substitute this condition, the maximum power condition, if you substitute, I'm sorry, you can put it into the RS. RS equal to RL. So I think better to follow this. If you, yeah, if you substitute this value into the equation, okay, then you can get the maximum power. So what is that? On the top is Vs square, you don't need to go. And Rs will be what? RL. So your load resistance value, RL whole square into RL. Hey, what happened? Can you do it now or still cannot do? Sir, I don't know how to simplify it. What happened?
Yes, sir, we can do it now.
Tell me what is that? Not you can. Vs square divided by what? Hey, I'm asking one by one. Tell me the truth.
4 RL, sir.
Okay, I'm just telling you. Jihad,
Sir.
hey, are you having a paper and pen with you in front of you? No.
Yes, sir.
Tell me the truth, remember. Naushin Tarannum.
Yes, sir.
Yes, sir.
Naushin, you have a paper and pen with you in front?
Yes, sir.
Good. Akib Hussain,
Yes, sir.
if you know, just tell me no. It is not that you have to tell me the lie. I'm not going to give you the marks. But if no, you should have. That's what I want to tell. Akib, are you really having?
Yes, sir.
Okay,
Yes,
if I ask you to open the camera and show me, can you show me? Akib, you'll be in
Yes, sir.
trouble. Okay, good.
Yes, sir. I can
Okay,
show you.
good. No problem. Thank you. Muntasir Ahad, maybe I can ask
Yes,
you to
sir.
show me. Hey, I can ask you to show me in the camera. Maybe. Be careful. Tell me the truth. Muntasir, do you have it?
Yes, sir.
Okay.
Yes, sir. Yes, sir.
Okay, I'll ask whom to show me. Anam Al Ahad, you're having the paper and pen. He is caught. Anam Al Ahad, very busy with movie. Okay. Fariha Khan, you're having the pen and paper. Fariha? Okay. Gaurav Shah,
Yes, sir.
you're having pen and paper?
Yes, sir.
Good. Jawata Afnan,
Yes, sir.
having the pen and paper with you?
Yes, sir.
Excellent. Anam Al Ahad and Fariha Khan, two of you, I'm confused. Okay, if you are not
Sir,
having
they're texting.
what,
They don't have mic.
their mic is
Check the group chat, sir. They're writing over there.
okay. I understand. Both of them returned. Mic is not available. Okay, there are 5 chairs there. Okay, Fariha Khan. Yes, sir. I am on the desktop. Who is Anam Al Ahad? Anam Al Ahad. I don't have the mic and camera. Okay, only speaker. Sir, my audio has some problem. Okay, my question is, do you have the pen and paper or not? You should tell me yes or no. Fariha, you written, you have audio problem, no problem. But you can see and you can write. You have a hand problem to write and you have a problem, no paper at home. Fariha, you have, write it down. That, yeah, I have, sir, I have the pen and pencil. I have the pen and paper I am having. Fariha, yes, sir, I have pen and paper, but that's it, okay. And Anam Al Ahad, you don't have anything, my camera, nothing. What do you have then? Okay, Anam Al Ahad, yeah, you don't have pen, paper, good. All right, no problem. Thank you very much. Now, let's come back to the point. You should come to the class with this, otherwise all meaningless. Okay, Vs divided by, one of you said the answer. What is that? Vs divided by 4?
Or
RL.
RL.
RL. So this is what our power max equation, P max equation is this. That means at this point, all of you look at it, at this point, the value will be Vs divided by 4RL. Remember, this is the maximum power, P max. P max equal to Vs divided by 4RL. So everybody can easily understand that the maximum power value is Vs divided by 4RL, and at this point we can get the maximum power. Beautiful. Now I'm going to show you an example and you tell me from this example. Okay, I'm going to give you a source like this, and I'm connecting a load with this. Okay, what's wrong here? Just a minute. Okay, let's see if it works. Yeah. Okay, that means something on the screen I am having problem maybe. Yes, sir. Okay, now what happened? This is your RL, let's say, and this is what I'm writing here. There's a 2 ohm resistor, and this may be a 3 ampere. Okay, what is this? What is this source?
Time source.
Yes. So this is supplying the voltage. It's supplying the power load over here through this, and you are going to go. So I'm asking you, what is the Pmax in this circuit? If I ask you, what is the Pmax delivered to the load? Anybody can tell me the answer. Find the solution. You have the paper and pen to draw your girlfriend or boyfriend's pictures. Do it and tell me the answer. If anybody can do it. Okay, how to do? You first, what you will do? Anybody can tell me what is the first step?
Source transformation.
Good, source transformation. If you go for source transformation, you get the answer. Okay, if you could do the source transformation, what is the thing coming then? This is voltage current source to voltage source. What will the voltage source value and resistance value? Can you tell me what is the voltage source value? Vs will be what?
6 volt.
Yeah, excellent, 6 volt. And this one will be?
2 ohm.
2 ohm.
2.
So you all get it. Now you can easily find what is the power maximum power transfer to the RL. What is the maximum power transfer to the RL? Find it now. Very simple from the equation. Okay, for the maximum power, what should be the value of RL? Anybody?
RS.
What is that value?
2.
Sorry?
2.
2, good. It will be 2 ohm. This 2 ohm will be coming here, which is nothing but RS. This is RS. So RL will be equal to RS. Now, what will be the power? Very straightforward. What will be the power?
4.5 watt.
How you found it? What is the equation? Adak, what is the
V-
equation? Yeah,
V square by 4RL.
right. Vs divided by 4RL. And Vs is what? 6, and RL is 4 into 2. So what is the answer?
4.5 watt.
Oh, Vs square, right? Vs square. Okay. 4.5 watt. Are you all getting the same answer?
Yes, sir.
Okay, good. I hope that everybody understood. Now, what I'm going to draw this diagram over here, all of you try to look at it. If you draw the diagram like this, for this circuit I'm analyzing, okay, like PRL is 0. The curve I'm going to draw, a curve is coming like this, like that. And for that circuit, you got the RL value and you got the maximum power here, Pmax. Pmax at this point, you got it. So my question is, what is the value for that circuit we got here? What is the value we got there? can you tell me what is the value for that circuit we got here, and what is the circuit, what is the value here? Can you tell me first? The resistance RL value, what is that value?
2.
2, good, excellent. So we got the RL value is 2 ohm is the, at that time you get the maximum power. What is the maximum power P max we got?
4.5.
4.5.
Excellent, good. So 4.5 watt. So you all understand this example very well. Yes,
Yes, sir.
good. Now, very careful, follow me. Okay, now if I say that if RL equal to 1 ohm, then that means if RL equal to 1 ohm means if this one is not 2, rather if it is 1 ohm, if RL equal to 1 ohm, not 2 ohm, but 1 ohm, then what will be the power consumed by the RL, PRL? What will be the power? Can you do the calculation? Tell me. If it is 1 ohm, not 2 ohm. 2 ohm is the maximum power you get. But if it is PRL equal to 1 ohm, then what will be the power? Can you calculate and tell me? Anybody? Do it on your paper. And lazy ducks, just sleep. Wait for your friend to do it and then copy paste. Go back home. Okay, if anybody can tell me, tell me. I'm looking at your picture. Who can tell me? This is the main advantage of live class, actually, that you are going to work with me. Looking at the video is like looking at the movie. Just one-way communication. Okay, now let's come back to the point. Anybody can find the PRL? And I'm getting your performance.
Sir, 0.44.
0.44. Okay, can you tell me what is the equation you use to calculate? What is the equation first?
Sir, B square divided by RS plus RL whole square into RL.
Excellent, beautiful, absolutely perfect, beautiful. Now you tell me what is the value? Vs equal to what?
2, sir. 2.
Vs equal to 2. You better dig and go to the graveyard and save everybody.
No, sir, it will be 3, sir.
Or you are
Sorry,
dumb.
6.
Vs equal to what?
6.
6.
6. You cannot see the Vs here? Oh, I'm sorry, you cannot see. Okay, can you see now? This is what? Vx.
Yes, sir, it's 6.
Yes. Why 2, 3? What motivated you to tell me 2, 3? 3 is ampere. It's not voltage, right?
Yes, sir.
So tell me what is Vs. I know that your answer is wrong, but you follow me. You tell me the correct thing, then that will be great. Vs will be what now? 3 square or 2 square?
6 square, sir.
Good. 6 square. Good. And Rs is what?
Sir, 2.
2. Good. And RL is what? 2.
So 1
Good. Absolutely good. Into 2.
into 1.
Absolutely good. Now, Gaurav Shah and other ducks, can you tell me after calculation, because he made a mistake, what is the answer?
4 watts.
4 watt. All of you got 4 watt.
Yes.
Somebody got 5 watt, right? Not correct. 5 watt. Somebody got 5 watt? Hey, what happened? Anybody got 5 watt?
It's 4.
4. Because if somebody say, I don't know how to do this calculation. Okay. If somebody get 5 watt, it does not make sense. Can anybody tell me why?
Our maximum power is 4.5, so it cannot be greater.
Beautiful. Maximum power is 4.5 watt. So it cannot go more than 4.5 because it will exceed the maximum power. So it is wrong. If you get more than 4.5, your answer is wrong. You got 4 watt, makes sense, which is less than 4.5. So it makes sense. Yeah, you are right. Everybody got it?
Yes, sir.
Okay, now let's go. Hey, look at it. 1 ohm. 1 ohm is on the right side or on the left side of 2 ohm. 2 ohm is here. It is 2 ohm point. 1 ohm is where? On the left or right?
Left.
Right.
Left.
This
Left.
is left and this is right. This is left, this is right. Which way? Left or right? 1 ohm.
Left.
Left.
So why is the right? Are you dumb or what? Okay, now look at it. It should be the left side. Right will be more than 2 ohm. So if it is 1 ohm, so assume this is 1 ohm. And then you go tick, 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 tick. Okay, 1 ohm and intersecting the curve here. And you go tick, 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 tick. Okay, here. Now, this is the way if it goes. Can anyone voluntarily tell me what should be the power at this point?
So 4.
Who said for Jihad?
No.
Akib Hussain. Who?
Muntasir has, sir.
No, sir.
Oh, you Jihad or what? You who?
No, sir. I'm not Jihad, sir.
Okay, I'm just going to see because I'm just taking the class performance actually. There's nothing else. Remember, you're coming to the class and you show your performance. I want it. And those who are not coming, they are missing this opportunity. And when marking the script, it have a good impression about you. So everybody be active in the class, please. Okay, you make a mistake, no problem. But I want to see you are working. You're not a sleeping partner. Okay. It is 4. It is 4, as you said. Absolutely correct. Okay, can you see the screen in or some block thing there?
No, sir. It's
No,
okay.
sir. It's
Okay,
clear.
We can see the
okay,
screen.
good, no problem. If any disturbance anytime, please let me know. Okay, 4 watt here. I think absolutely correct. 1 ohm gives you 4 watt. Now, everybody look at it. This 4 watt, if you extend the line, ting, 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 and it is intersecting the curve at this point. So this 4 watt, this is also 4 watt. This is also 4 watt. These 2 points, both points are 4 watt point. And the second 4 watt point on the right side also coming for another resistance, right?
Yes, sir.
So what can we see? The 4 watt we can get, the 4 watt we can get for two different resistance. One is 1 ohm, another one is this duct. Now what is that duct on the right side? It gives you. So other than 4.5, every resistance, I mean every watt can be obtained for 2 resistance other than the Pmax, because Pmax is giving you only for 1 resistance, which is RL equal to RS. That's only 1 resistance. But other than 4.5, any one you go here, any wattage will give you for 2 resistance. One is on the left hand side, one is on the right hand side of the 2 ohm. Right? You all understand it? Yeah.
Yes, sir.
Now we got 1 ohm gives you 4. We can see here this 4 also we can
Yes, sir.
get for another resistance. And what is that value? Question is how to find it. Let us see. We can find it from here. Our PRL equation gives you Vs square, the basic equation, Rs plus RL whole square into RL. There's a basic equation. So what is the power? Power is 4 watt, right? The voltage is 6 square. RS is 2 ohm. That is what the RL we have to find. For which RL we are getting 4 watt. Now, from there, you can see if you want to solve the RL here, this will give you a what? This will be giving you a quadratic equation, right? You understand quadratic equation. The first time you hear this quadratic name. Have you heard the quadratic before?
Yes, sir.
Yes, sir.
What is this? X square bx plus c equal to 0. And what is x equal to? You get a 2 value here, right? 2 value. Like that, if you find what is the quadratic equation and what is the RL value, you get a 2 value here, right? And one value you already know. What is that? Can anybody tell me what is the one value?
4.
Ah, you're dumb. One value.
One,
RL
sir.
is
One.
one. Right. Absolutely correct. One value is one. Another value we are looking for actually. So one value already, you can find it. You will find it one as well. What is the second one? That one comes from here. Now do it and tell me the answer, please. Go. Too much relaxed life. Online class, you are sleeping and just doing the class. You are not doing anything, just listening. In my class, you have to do some work. It is boring job. And that's why some of the students dropped. Don't like this sort of work. Okay, anybody can do it, tell me the answer. If you give me the answer, I'll ask you what is the quadratic equation, and then you have to tell me the quadratic equation. So what your first job is, find the quadratic equation and then you solve what is RL.
Sir, I got RL equals to 4 and 1.
Okay, you got RL equals to this one you
4
got
and
4.
yes.
Okay, now my question is, does it make sense? Yes or no? Yes. Why it is make sense? Because this must
It's
be
on the
more
right
than,
side.
yeah, it must be more than
Yes.
2. And you got 4. 4 is more than 2 because on the right side. So that is good. Now, who is that? Tamannum.
Nom, sir. Yes.
Naushin Taranum. Naushin, tell me, what is your quadratic equation? Tell me first.
Sir, 4 RL square.
Hang on.
My,
4 RL square minus?
minus 20 RL.
Minus 20 RL.
Plus 16.
Plus 16 equal to 1000. 0. Okay, now everybody copy paste. Those who are very reluctant to do what. Okay, and then from here, if you find the value, you get 1 and 4, or you can just substitute 4 into the equation. Is satisfied or not? Yes, then it's okay. And 1 also. This is a formula you can just apply and then you get it. I hope that all of you understand how to find it. You don't need to waste time. Now we can go back to this, and what we can do here, we can substitute this value. We can substitute this value here as this is our 4 ohm. So at 4 ohm and at 1 ohm, we are getting these two values, which is 4 watt. So 4 watt power can be obtained for this 2 resistance. Okay, I am going to ask you all to do one thing. If I want to go for 3 watt, find, question is here, find RL for P equal to 3 watt. So if I want to get PRL equal to 3 watt, then what will be the value of RL? Everybody do it and tell me. Naushin, you understand, I hope, that what to do. Go faster and do it. What to do? Just this thing you have to change, nothing else. Only this thing. What will be this value?
So 3.
3. If the whole equation will be changed, and then the whole result will be changed. That's it. Do it and finish. Then we jump to the next problem. Have you done it a bit faster? What is the answer?
Sir, I got 7.46 and point
Point what?
and 0.54.
0.54 ohm, and
Ohms.
another one is what?
46.
7.46 ohm. Oh, these two
Yes,
things.
sir. I
Okay,
got
fine.
the same, sir.
Same. Okay. Who got the same?
Sir, Jihad.
Jihad, you tell me what is the
Yes, sir.
quadratic equation?
Sir, equation 3RL square,
3RL
3RL square
square, then
minus
minus. Hang on, just a minute.
minus 20,
Just minus.
24RL
Mm-hmm.
plus 12 is equal to 0.
Tarannum, correct or not?
Yes, sir. I got the same thing.
Excellent, good. So let's go back. Rest of you take your lollipop out and then copy paste and let's go with those. Don't need to do it wasting time. Now look at it. So 3, if it is 3 here, if you go to this line, absolutely ting ting ting. So this is the intersection point. This is the intersection point. So these are the two values we are getting here. One is this resistance, another one is this resistance. So we can easily find it. What is the value of this resistance? Now, this is your what? This value will be what? This value 7 point something, right?
Yes, sir.
Yes,
7.46.
sir.
7 point. Look at it. 7 point. This one will be 7.46, right, Tarannum?
Yes, sir.
You kill yourself, yes, sir.
Sir.
Which one? Oh, sir. Right side is 7.46.
Where are you sleeping or where are you looking at watching movie?
I was looking at my coffee.
Okay, no problem. I understand it. Everybody look at it. This cannot be 7.5. 7.4.
0.54.
Yes. No, why you are also sleeping or what? Not looking at this, what I'm writing here. 0.54.
0.54.
Good. This should be on the left hand side. And this should be 7.46 or whatever you got. So good. I think then you all understand actually how to find the values. So in the exam, question will be like this, that you have to show the, power diagram. Remember, then power diagram will be like this. And in the power diagram, you have to show where is the maximum power, what is the value of the maximum, at what value of resistance you are getting that power. These are the ways you have to show in the power diagram. You can see final exam question, most of the questions are asking that draw the power diagram at the end of calculation. So you need to draw these things. I hope that you understand, you can easily draw it. Okay, the second problem I'm giving, and after that we're jumping to the dependent source problem. Now let's come here. Example 2, all of you please copy the example 2 faster. I'm going to draw, and the example 2 is like this. Okay, plus minus, a battery here, a battery here. This is the application. Actually, this I'm going to tell you. This is okay. This is your RL. Here we go, A and B terminal. So this is your RL. This is your plus minus. This is your plus minus. Okay, and this is 2K. I'm sorry. Okay, now look, all of you. Okay, yeah, shut off your microphone if you have any important job to do. Now look at it. This gut is your 2K. This gut is your 2K as well. And this one is 20 volt. This one is 30 volt. And this is 40 volt. Okay, now the question here is, what is the question? Question number A is, if the RL is equal to 3K, then find PRL, P3K equal to what? Number B, I'm writing shortcut, and find the Pmax. Find a Pmax. So one thing, question. And number C, you have to find RL equal to what for PRL equal to 20 milliwatt. That's what your question. Now, have you copied? Bit faster if you had copied.
Yes, sir.
All right. Now, all of you copied. Just get a screenshot. That should be fine.
Yes, sir.
Okay. Now let these things. I'm going to give you some information about these things. How the Thevenin's theorem, the Thevenin's application. This is the Thevenin's application. Why? You look, last time we did a solution like this. Last time I told, when I taught you the Thevenin or whatever the Norton Thevenins we have started last time, I've shown you this circuit like this, as complicated circuit like that, and voltage current source, whatever, and the resistance things. And I told that if this is A and this is B, and this is the variable RL, so A and B point here. So in this complex circuit, our target is to find the changing value of RL, and then every RL value, we will find how much power the RL is consuming here. And maybe we can say what will be the maximum power it is consuming, like sort of things. Then what can we do? We don't need to calculate the whole complicated circuit again and again. What Mr. Thevenin said, hey, Dax, you don't need to go for it. What you can do, you can, can remember it, right? This is the way you have to simplify the whole complex circuit and make a simplified form. And this form is called, what the name is what? Thevenin. So we call it as a Thevenin theorem. So if you go for Thevenin's theorem, then we can connect it back the RL here. So your RL is coming here like this. Okay, so this is what, in that case, this is your P plus minus. What is that? Is E Thevenin, and this is your R Thevenin. Remember?
Yes, sir.
Yes, sir.
Excellent. So the whole complicated circuit, we can change it into this.
Yes, sir.
And then we can get the form like that. And it looks like our today's circuit, which is maximum power theorem, and where we have written this is Vs and this is Rs, right?
Yes,
And-
sir.
Yes, sir.
Okay, so we can straight away replace the Thevenin circuit by this maximum power transformation circuit. It is the same thing. So what can we do? We can say that this complex circuit, we can convert into a Thevenin theorem, and then we can, from here, if I can say, hey, Doc, what will be the value of RL? At what value of RL we get maximum power? What value of RL? Can you tell me? Maximum power. Today we have seen, we have derived the equation.
RS equals to RL.
Right, RS equal to RL. That's what you have found. Here, RS equal to RL. So you are going to see this RL will be equal to RS. But we are talking about the blue circuit, Thevenin circuit. So it will be equal to what? The blue?
R Thevenin.
R Thevenin. Good. So we can say the same thing. So if the load resistance, in this case, the load resistance is equal to R Thevenin, that means it is equal to RS. Means at this time we can get the maximum power, and that maximum power P max will be equal to, as it is, what is that, 4 V square. V square means V Thevenin, E Thevenin, right? Vs square, you know maximum power. What is that? Maximum power is what? V, what is the formula? Vs square by 4 RL, right? So in this Thevenin's theorem, it will be V E Thevenin square is Thevenin square by 4 RL. RL means R Thevenin, you can say as well, R Thevenin as well. So you are getting the equation like this, same thing. So what does it mean? It means this Thevenin theorem can be applied to get this Vs and Rs, which is nothing but V Thevenin and R Thevenin. And then you can put this into the equation and you get your power, maximum power, and you can get at what RL you get the maximum power. This is what the application of Thevenin's theorem. This Thevenin's theorem can be applied for complicated circuit. This is a complicated circuit, and you are going to change the load. And in this complicated circuit, you want to find at what load the maximum power we can get. Then what to do? Every time you don't need to calculate, just find out from this and find the equivalent R Thevenin and find the equivalent voltage. These two things, if you can simplify, then straight away from this equation you can find what will be the maximum power transferred to the RL. You understand me? Are you sleeping?
No, sir.
You understand the point what I mean?
Yes, sir.
Okay.
Yes, sir.
This is the question. The question is a complicated circuit given to you. When you get a job in Ranks Electronics, they will ask you, hey, this is a circuit. You tell me at what will be the maximum power this resistance can absorb from this circuit. And as an engineer, you look at him and say, I don't know. You backfire. Now, how to do it? You do these things. You will just find the equivalent of this thing and find the Thevenin's equivalent and the Thevenin, R Thevenin and E Thevenin from here. And then from there, you can straight away equation and you find the value and tell him that at RL equal to when it is equal to R Thevenin, what value you get, let's say 2. So you say when the load resistance is 2 ohm, then you get the maximum power. What is the E Thevenin? Let's say 5 volt. So it will be 5 squared divided by 4 into 2. You calculate and tell that to your boss that this is the maximum power is this load resistor will absorb from this circuit. You understand me now?
Yes, sir.
Yes,
Yes,
sir.
sir.
Because money matters, job matters. Otherwise, you lost the job. Everybody concentrated and understood. Earlier, no. Okay, now let's come back to the point. If you understand it, the problem example 2 is similar, very similar thing. So if you want to find what will be the RL value so that maximum power can be absorbed, or what are the power it takes or something like that, we have to find it. Then what you have to do here, this complicated circuit, you have to first apply the Thevenin equivalent. If you can find the Thevenin equivalent, then your RL you can connect and RL equal to R Thevenin. From there you can find the power max or like that. So all what you have to do is you have to find the like this. This is the contour. This is the complex circuit. Like the blue contour, you see the blue contour, the blue circuit, your equivalent Thevenin, like that. This is the blue contour. You have to find the equivalent of the Thevenin. Okay, now you go for Thevenin equivalent. I'm sorry, for Thevenin equivalent. And then you bring back the RL, the black duck RL here, and then you can find it RL equal to what? Okay, now all you have to go for is what is the value of R Thevenin, what is the value of E Thevenin. That is your main job now from here. First job first. After that, you go one by one solution. You understand me? Hey, ducks,
Yes.
what happened? Understand?
Yes, sir.
Okay, if yes, can any one of you tell me what will be the R Thevenin? Because this is the first job and everybody should know how to do. What is the value? Just tell me. You can tell me straight away looking at it. R Thevenin is very straightforward. You remember the Thevenin equivalent. You look it into it, RAB, you take it off and RAB, and all the sources should be deactivated. And what is the resistance? Anyone? Oh, Thevenin equivalent resistance, if you don't know, R Thevenin.
Sir, 1.
1. Good. How you got 1?
Paralleling the two resistance.
2 parallel 2 is 1K. 1K. Good. So you write here, it is 1K. That's done. R Thevenin is done. Are you confused, any of you? Or everybody understand R Thevenin? Hey, are you okay? Everybody understood R Thevenin?
Yes, sir.
Okay, anybody got question, please tell me. Akib Hussain, you okay?
Yes, sir.
Okay, good. Now, if anybody have any question, please let me know. If you understand R Thevenin, it's fine. Now you go for E Thevenin. E Thevenin, how to find? If you find E Thevenin, you can see here. E Thevenin means you open this. That's just Thevenin equivalent. You just find the Thevenin, just take this resistance out. And from AB terminal, you just look from the AB terminal and find the EAB, right? EAB. EAB equal to what? That is your Thevenin equivalent. I told you several times in the last class. So EAB will be what you have to find. If you find EAB equal to what? Open circuit voltage, then you come from here and come back here. This is the point. So starting from this point, if you go, then the minus 40 minus 40, yeah, minus 40, then plus 30,
Sir,
plus 30, yeah.
I have a class right now. Can I leave?
Yeah, you please, those who are having class, you please leave the classroom and check the video later. And those who are not having
Thank you,
class,
sir.
yeah, those who are not having class, you please stay back. It will be, because I have to upload it. I'll upload it in the box after finishing this. Okay, so minus 40 plus 30, because this is minus, this is plus, this is plus, this is minus, or this is plus and this is minus EAB. So if you go minus plus and then this is plus, this is minus, because I assume the current is flowing through this. If you assume current is flowing through this, last time we solved a problem like that. If you follow that, because this is open circuit, no current flow on the right side, so all coming through this loop. The loop current is I. If you follow I. Last time we did I current flow, right? I current flow. Okay, if you follow this, then it will be what? Minus minus plus, plus 2 into I. Plus 2 into I. 2 is kilo ohm, so I is milliampere. So 2 into I. And now from here, you have to go for minus 10 plus 2I. Now you have to find the value of I equal to what? That means in this problem, your first step is what? First step is you have to solve the Thevenin equivalent first. You have to find the Thevenin equivalent and then you do the second part. This is the way you have to do it. So Thevenin equivalent we are finding. So if you want to find I equal to what, then you have to find the KVL. So KVL into this thing. So KVL. So what is the KVL equation here? If you go, then you go to this is plus minus, this is plus minus, this is plus minus. Now, how many voltages are there? 4 voltages are there. So what are the 4 voltages? Anybody can tell me what are the 4 voltages? Starting from 2K minus 2I, then what? Then minus 20, 2K, then minus 20. Then next, what is the next voltage? Can anybody tell me?
Minus 30.
Minus 30. This is the loop. Minus 30. After that?
Minus 2I.
Minus 2I. Now, all what we got equal to 0. Now, can you tell me what is the I coming from here? Anybody can calculate. So 4I equal to 50. If 4I equal to 50, I will be equal to what? 50 by 4. 50 by 4 equal to what? Hey, 50 by 4?
12.5.
12.5 milliampere. So this is the I current, and this I current you have to substitute into this equation. And what do you get now? 10 plus 2 into 12.5. What is the answer coming then? Anyone can tell me the answer?
15.
15.
Yes, sir.
You mean this one? 15 volt. All of you got something like this? EAB? Oh, okay. I is
Sir,
no, hang on.
minus
One thing.
2.8.
Yeah, is it I equal to plus or minus?
Minus, sir.
Hey, 12.5. Somebody told me. Is it minus or plus 12.5? It is minus 12.5, isn't it?
Yes, sir.
So you should not make a mistake. If it is a minus 12.5, then what will be the answer coming here? Because you have to substitute here minus 12.5. So this is plus 2 into minus 12.5. And then what will be the answer coming now? Then what will be? Is it 15 still? Now what is the answer?
So minus 35.
Minus 35. So it is minus 35 volt. So if it is minus 35 volt EAB, if minus 35, then your here the Thevenin voltage is minus 35 volt. If minus 35 volt, so RL equal to this, R Thevenin is Thevenin. So you can get the equation now like this. So you can solve one by one question now easily. So let us go with the first problem. Hey, all of you understand up to this? This is what we
Yes, sir.
did. Yeah, we just find the Thevenin equivalent. We did not start answering our question yet. Now we are going to answer because we are up to that level to answer now. I'm going to delete it. I think this everybody understand. Okay, now look at it. What to answer here first? The first answer is this. This one is here. We have to find what is the P3K. That means if the resistance RL is 3K, then what will be the from here, if 3K equation is coming as Vs square, which is E Thevenin square, divided by RL plus RS. So R Thevenin plus RL square into RL, right? This is the formula. So you can substitute. E Thevenin is minus 35 whole square, Vs square. I'm talking the Vs square. Hey, you understand this equation? Vs square divided by Rs plus RL whole square. You understand it?
Yes, sir.
Yeah,
Yes,
that's the equation we got from here. Okay. Now divided by R Thevenin is your 1K and RL is your, what is RL? Hey, RL equal to what? You duck.
RS.
What is the value? What is
RS
it?
oh, 1K.
Not one. Look at the question. I am
3K, sir. 3K.
Oh,
I'm
3K,
circling here.
3K,
RL is
3K,
giving me a
3K.
3. So for 3K, what is the value? I can just find it into what? Can you follow me? Into what?
Into
3, sir. Into
Right.
3.
That's it. And that gives you the answer. Now tell me what is the answer you get. You should be ready with the calculator, please.
Sir, 229.68.
Okay, we can say approximately.
Yes, sir.
What? Approximately what? 200?
30.
230. Okay.
230.
29.69.
Oh, 29 is 30. Come on. I'm talking about approximate. 29 means 230. Can we write? No, sir. 229.999.
Sir.
Okay. So now can tell me 230, approximately 230. What is the unit? Is a watt or watt a tang tung? What is that?
What?
No.
What?
Because no, this is kilo ohm. And this is a kilo ohm cancel out. 10 to the power 3 will be at the bottom. So 10 to the power minus 3 is there. So it will be 10 to the power 3 will be there. So it will be what? It will be milliwatt. This is kilo ohm. This 1 kilo ohm, 3 kilo ohm. Just check it. Substitute kilo ohm. Kilo ohm means what? 10 to the power 3, right? So 1 into 10 to the power 3, 4, 3 into 10 to the power 3 into 10 to the power 3. And then you do it. And then you can see it is giving you this thing. So the 0.23 into 10 to the power 3. Okay, that means this is milliwatt. A 0.23 watt you can see here. So whatever you can do, you can say. Yeah, this is very simple thing. You should understand it. I don't need to tell you. How come you said, because kilowatt is a I'm sorry, this is kilo ohm, right? Kilo ohm means what? Is a watt, you get the milliwatt. Okay, so you can check it. You get it to point, if you convert into kilo ohm to ohm, and then you do the calculation, you will get 0.23 watt. Okay, or you can say 230 milliwatt. Now, the answer is what for this case? Hey, you understand what I'm talking? 230 milliwatt. Do you understand it?
Yes, sir.
Yeah, yes,
Okay,
sir.
I think you should not be confused. So the answer here we got, the answer is 230 milliwatt for the first one. Pmax, go to Pmax here, the second part of the question. Pmax equal to what? Hey, what is the equation for Pmax? Anybody?
V square by 4R.
Good, absolutely. V is what? V is E Thevenin. E Thevenin square, right? Hey,
Yes, sir.
what happened? V, where you get V? V is here, E Thevenin, right? Vs square means E Thevenin square. Do you understand what I'm talking?
Yes, sir.
Okay, then
E
E
Thevenin
Thevenin is
squared
squared by
R
4
Thevenin.
RL or RL or R Thevenin, whatever you say, because they are same for maximum power. RL and R Thevenin is same. So what is E Thevenin? What is E Thevenin? E Thevenin is minus 35 square, and this is 4 into RL is what? R Thevenin is what? Hey, what is R Thevenin?
1, sir.
1. So 1, and then now you do your calculation. I think you have done it already. What's the answer? Oh, you haven't done yet. You are dumb or what? You know how to use calculator. Any children can solve the problem by this time.
Minus 306.24.
Can you kill yourself? Where you get minus? This is minus. This one is like
Minus
that.
0.31
But plus or minus?
plus.
Why you say minus?
Plus 0.31.
Who said minus? And the minus 35 whole square is plus. Okay. 0. Yeah. What is that? I'm sorry. Come again.
0.31.
So 0.
31 what?
What? And then if you convert, because it's a milliwatt and everything is in milliwatt, if you convert into milliwatt, what will be the milliwatt then?
So I converted it.
What do you mean by convert? You multiply by 1000, you get it. What is that? Ducks.
Yes, sir. After multiplying.
You need a calculator to do it. 0.30 something multiply by 1000 is going to be what? Hey, anybody cannot tell me. She said
306.25.
yes. 306.25. Approximately 306 milliwatt I can write here, no problem. Hey, who said I have to multiply by 1000 and you gone to search for the calculator? Is it? Hey, do you understand? She said 0.3 something, 0 whatever 6 something like that. What? I said how many milliwatt? And you are looking for calculator.
I thought you wanted the watt value.
No, it's all right. Now you understand what to do. You multiply by 1000.
Sir, yes.
You get a milliwatt. And everybody understood. Hey, please tell me, everybody got it?
Yes, sir.
Okay, if you
Yes,
understand, now the real game, the question number C, can you do it? What to do? Anybody can tell me for question number C. Yeah, what equation you should follow here? Tarannum, can you tell me? I think
Yes, sir.
you did last time.
PRL equals Vs square by Rs
Excellent,
plus RL.
beautiful, beautiful. So in this case, Vs means what? E Thevenin square, right? And R Thevenin plus Rs means R Thevenin plus RL whole square into what, Tarannum?
RL.
RL, beautiful, good. So this is PR equal to this equation, you know, and this case the PRL is 20. So 20 equal to this. This is the equation you are getting. Among this equation, you look, you know the E Thevenin square. E Thevenin square is what? E Thevenin square is minus 35 whole square. Vs square is minus 35 whole square. And you know the R Thevenin. Hey, what is R Thevenin?
1, sir.
1.
One.
Good, excellent, beautiful. R Thevenin is 1. So I'm putting here 1. So only the thing is, in this equation, what is unknown? Hey,
RL.
RL. So you have a quadratic equation. Last time you did exactly this time. You get a quadratic equation. From there, you have to get 2 value. 1 value RL, 2 value of RL you are going to get. That's your answer. For RL means there are
RL.
yeah, you will get a quadratic equation. Remember, you did last time?
Yes, sir.
Like this, you have to find here also same way the quadratic equation you have to find, and from the quadratic equation you can find the value of RL. Okay, I'm not going to go for waiting for solving. This is a bit longer thing. I'm giving you the answer. You note it down and you try at home. You can get the same answer or not, or next class I can show. Now write down the answer, what you will get. RL, first answer you get is, please note it down, 39.2. I'm sorry, 59. Can you check, can you please wait for a second? This is, okay. Okay, RL equal to, please write down 59.2 K. Another one is, and there are two answer quadratic equation. Another one is your 16.88, 16.88, not kilo, it is ohm. Remember, or 0.016 kilo. So all of you note it down that 16.88 is not kilo, this is ohm. And another one is a 59.2 K. These are the two answers you should solve at home and find from this quadratic equation. You all okay? Hey, is it okay?
Yes,
Yes,
sir.
sir.
Good. Now, I'm going to solve one more problem, and that's the end of the class. And that is the most important thing because of some sort of, what do you call that? Same type of thing. That is, you have to find the Thevenin's theorem, and from the Thevenin's theorem, you have to find the maximum power transfer, like that. So you need to go for finding the maximum power transfer for this problem. Now, but in this case, it is also same. In this case, also same. What we have done just now for this problem, the question will be coming from here like this: that find the Thevenin theorem, find the Thevenin equivalent, and then solve the maximum power question A, B, C. Okay, first of all, find the find the, what do you call that, Thevenin equivalent, which you have done already. After that, solve the problem A, B, C. So question will be like that in the exam. So what is this? This is the problem. Example 2 is the problem, which is the combination of two things. What combination? Hey, the Thevenin theorem as well as the maximum power transfer theorem combined together in this example, example 2. Do you understand it?
Yes, sir.
Yes. So the final exam question of next question will be coming like that. These two theory combined together, Thevenin's theorem and maximum power transfer theorem. So I hope that all of you understand it. Just I'm going to show you, tell me the graph for this problem, for particular problem. Actually, I'm just going to show you the graph and you can tell me, just to get it clear, and then everything is done for you. RL. Now look at it. If I ask you that question, hey, what is the maximum power for this last problem, example 2? Can you tell me, example 2? Hey, what is the maximum power here? Just tell me, what is the RL here? What is this value, RL? Anybody? RL equal to what? Maximum power we got at what RL? Example 2 just now we solved. Okay, what is the maximum power we calculated? Taranum, are you there?
Yes, sir.
Pmax is what? You get one number, question number B.
Yes, sir. 0.306.
0.306. That means 300. You can just say the 3 milliampere.
306.
306 milliwatt. Okay, fine. Good. This is the maximum. At what resistance you got?
1K.
1K. Good. At 1K, you are getting 306. This is your RL. RL equal to this equal to R Thevenin. What we got, maximum power, we got it. For graphical representation, you need to have a clear idea about it. Okay, first question said at 3K. At 3K will be on the right side or left side. I'm talking about question number A. A, B, C. A, B is done, maximum power. I'm talking about A now. For A, what is the thing is said? RL equal to 3 ampere. RL equal to 3K, right? 3K on the right side or left side? On the left or right? Right side. So let's say this is 3K. At 3K, what is the power you calculated? Can you tell me?
230.
Good. It is 230 milliwatt. Okay, that is what the graphical level. You should get this 230 for another resistance. You can calculate it from the quadratic equation, but it is not the question asked for. So you don't need
Right
to.
side.
Yeah. Now, no, once it's coming. Or right side 3 watt. That's okay. Now, question number C said what? 20 milliwatt. 20 milliwatt is somewhere here. Let's say 20 milliwatt. I'm just assuming 20 milliwatt. And 20 milliwatt you get for 2 resistance. And that quadratic equation solved. One is here, one is here. So what will be this value? What will be this value? You did not solve, I given you the answer. So can you tell me, right side value will be what? What will be this value?
59.2.
Absolutely good. It is 59 point. I'll give you the answer actually, 59.2K. And on the left hand side, what is this value?
0.016.
Beautiful, excellent. 0.016K. Now it is 0.016, you're right? It's a K. So this is the concept. Now this is the question D, you remember. Question D is show these parameters on a power graph, on power plot. The power plot, you have to label all these things. Whatever you got the value, all these things you have to show in the power plot. So this is the RL versus PL you have to draw, and you have to show all the parameters on the graph. All of you understand what I'm talking is, I'm talking about this. Hey, all of you look at it. This question number D will be here. Can you see what I'm writing? D.
Yes, sir.
Okay. Plot the PL versus RL. PRL versus RL. Like that. The question, third question, for the fourth question will be like that. And answer will be this thing. Actually, I didn't write the question. This is the answer for question number D. All of you understand what I'm talking? Jihad, you clear? Oh, Jihad left already. Akib, do you understand, Akib?
Sir,
You understand question number D?
not really, sir.
Oh, okay. The question number D said over there, all this power calculation you have done, A, B, C, you show it into the graph, power graph. That is the
Just
question.
I would be representing whatever I have done. That's it.
Exactly, in question number D. And that's
Okay.
what I have shown you here. So I think now it's clear.
Yes, sir.
Yeah, that's it. Your main job is done. This is the complete answer to the question. Now, all this is the problem we solved with the independent source. Then one more problem we are going to show, and that will be the dependent source problem. The same thing, you have to find the Thevenin equivalent and you have to find the power transformation, and your job done for today's class. We are going to end for today's class. We don't need to go. Can you just, a very simple short problem I'm going to solve. Those who can give time, you can stay and learn the thing. This is the last problem we are going to solve, and then we are going to finish the class. Example 3, which is based on the dependent source. So the question is, you have to find the Thevenin equivalent for this dependent source problem, and you find the maximum power, how much power is transferred, and your question answered. It is completed. Now, please, it is a little bit, you know that actually, not critical. You can easily solve it because you know dependent source problem, how to do. Look at it. It's 2K. This is 3K. You can create a snapshot, then it will be easy for you. No need to write it. This is 4,000. Okay, and this is your Vx. We are going to say that Vx is here, and this is plus minus Vx. Okay, this is what the question. You have to do what? Find the Thevenin equivalent circuit, and find the P max equal to what? That's it. If you can do it, the rest of the thing you can do by yourself. Whatever question comes, you don't need to worry about. So if you go for solution to this problem, the first thing is what? You have to go for finding the equivalent circuit of this thing. This is your Thevenin equivalent, means this is your point A and B. So you have to go for this blue contour. This is the blue contour. Jihad, we are solving the dependent source problem. So what is the question? Question says find the Thevenin equivalent circuit first, and then you apply the maximum power theorem on it to find the P max. Jihad, you understand it? Hey, Jihad, can you hear me? Okay, his microphone may not working. Okay, let's come back to the point. Uh, how to solve this problem? If it is a dependent source problem, we already know how to do it. Let us go and solve the problem first. First thing, in this dependent source problem, what is the first thing we do? We go for open circuit voltage, then we fall to RThevenin. First of all, VThevenin we find, then we go for RThevenin. So our target is to, yes, A and B.
Yes, sir.
Okay, Jia, this is the important problem because in the exam you will see this type of problem. So far, what we have done. Now let's come back to point. We have to find the Thevenin equivalent, means we have to find, this is what I have shown you last class. I think those who were present in the last class, you know that, or if you have gone through the video lecture, lecture 12 video, I have shown there the dependent source problem. So in the dependent source problem, E Thevenin you have to find first, and then you find the R Thevenin if this is dependent source problem. So E Thevenin, how you find? E Thevenin is you have to open this source VAB, and VAB means VX. VX means this is your E Thevenin actually. So VX will be equal to what? If you can find, that will be your E Thevenin. Now, because this is open circuit voltage. Since this is a dependent source, we should find E Thevenin first, not R Thevenin. I told you, but we can find R Thevenin how? Remember, R Thevenin we'll find later. What is the formula for R Thevenin? R Thevenin is V Thevenin by I Norton. Remember? So in this case, it is E Thevenin by I Norton, means I short circuit. We have to find it. So if you know the E Thevenin, then you can go for the other part. We'll do that later. But first of all, we have to go for E Thevenin. E Thevenin means what? VX. VX means whatever VX you get, that will be your E Thevenin. It's the open circuit voltage. That's it. Now, if you go for Vx, since it's open circuit, no current is flowing through that. The 0 ampere current is flowing through this. So Vx, if you go, the same Vx is coming up to this point. Same Vx is coming up to this point. So this is plus minus. This is also Vx. This is Vx actually. This is Vx. Do you understand it or not? This is important. Vx is the voltage across the current source, dependent current source. Do you understand it? This is very, very important.
Yes, sir.
Okay, good. But the current source value is Vx by 4000 ampere. Vx by 4000, this one is the current source value. But Vx is the voltage across the current source. These two things are different actually. Vx by 4000 is the current and Vx is the voltage. Voltage across the current source. And now, if you say this is the current source current is flowing through this, and this current will go which direction? To the right or to the left? Anyone? Can you see the current I am drawing here? This current will go from the source, and which way it will go? To the right or to the left? Or it will divide into two? What?
To the left.
Left. Because right side is 0 ampere, because open circuit, right? Open circuit means no current flow. So all the current is going through this. This is the circle. This is the current path it follows. Now, if current is going through that, then the voltage drop across is a plus and minus. Okay, plus and minus. So voltage drop across this. Now, if this is the thing, if we consider this loop to find the KVL, how many voltage in this KVL? Can you tell me in this loop, how many voltage? Bit faster. KVL, you know that. How many element? That many voltage. How many element in this loop?
3 element, 3 voltage.
3 element, 3 voltage. Good. Now, if you start from the first one, 4 volt. 4 volt is negative or positive? Hey, you duck. What happened?
Negative, sir.
How come negative? Voltage
Oh,
rise or
positive,
voltage?
sir.
So are you okay?
Oh,
So positive.
yes. Yes, sir.
4 volt positive, because it's a voltage rise. And then 2 K is also, this is a negative positive voltage rise, a positive. So you can write 2K. 2K means what? 2000, right? Ohm.
Yes, sir.
And this is into, what is the current? Can you tell me? The resistance into current is the voltage. What is the current? Current is what? Current is this current, the current source current, which is Vx by 4000. So it will be Vx by 4000. Do you understand it?
Yes, sir.
This current and voltage giving you the voltage. This current into resistance giving you the voltage. The whole thing is the voltage V2K. Do you understand it or not?
Yes, sir.
Okay, good. Now, what is the next? There are three voltages. One is 4, one is V2K, another one is what? You said 3 element, 3 voltages. Hey, what is the other voltage? Other voltage is the voltage across the current source. What is the voltage across current source?
So Vx.
Absolutely.
Vx.
So Vx will be what? Plus or minus Vx? Voltage drop, voltage rise. Oh, dumb.
Sir, minus Vx.
Right. It is voltage drop. So we are minus Vx and equal to 0. That's it. Now you clear.
Yes, sir.
Good. Now you see here, this 2000 and 4000 cancel out and it is giving you 2. Okay. And what is the Vx? Anybody can tell me the answer. This calculation any children can do a bit faster. Vx equal to what? Come on. Oh, bit faster.
Sir, 8.
8. Excellent. 8 volt. So your E Thevenin is 8 volt. We got it. Understand, everybody?
Yes, sir.
Okay. You all are confused about this thing. I understand from your background, isn't it? Or okay?
No, sir.
You understand this part?
Okay, sir.
Okay, good. Absolutely
Okay,
great.
sir. Okay, sir.
Absolutely great if you understand. So we have done the E Thevenin. All we have to do now the R Thevenin. In order to find R Thevenin, as I told you, the formula is V Thevenin by E Thevenin already you know. So you know 8. Now all what you have to go for the short circuit. Last class I told you, if you want to find the short circuit, then you have to draw the circuit diagram and you can show it. The circuit diagram look like 4 ting tang ting tang. Okay, so you can remember what was the circuit diagram shown, that 4 plus minus 4 volt. Then it is, what is the value, this one 2K, and then it is the short circuit, it is the, yeah, the variable, I think this is the dependent source, which is Vx by 4000. Okay, and this is the what, another resistance 3K, and this is your AB terminal. Now this is Vx, as you know, this is plus minus Vx. But in that in this case, short circuit current you want to find. What does it mean to find the? You have to short it. Remember last class I told you, and then you find the I
Yes,
short
sir.
circuit. That is your I Norton. That's what you have to find it. Now you short it. If you short it and find the short circuit current, if you short it, hey, if you short this AB terminal, Vx value will be what? Can anybody tell me what will be the Vx value? Short means, AB terminal short means, what is the resistance? What is the resistance between AB? RAB will be what? This is the thing, right? The voltage Vx will be the resistance into current. Current is I short circuit current, and resistance is what? AB resistance RAB. RAB equal to what? What is the resistance between AB terminal if I short it? Do you get my point? If I, hello? RAB will be what? If this two terminal is shorted, means what? The resistance is infinity. What happened?
Hello.
Huh? What is the voltage across this AB terminal? If the AB terminal is shorted or short circuited, what will be the voltage Vx between AB terminal? None of you can tell me. Ohm's law, if you apply,
0.
0. The RAB, why it is 0? Because the resistance is
RAB is 0.
short circuit means the resistance is 0. If resistance is 0, then 0 into whatever the short circuit doesn't matter, 0 volt you are getting. So Vx is 0. I think 1,000 times I told you. So this is the reason why it is 0, but it is 0. If it is short circuit means the voltage is 0. That is the way we know that, right? So Do you all get it? Why the Vx is 0?
Yes, sir.
Because we shorted the AB terminal. So the voltage Vx is 0. If the voltage Vx is 0, if the voltage Vx is 0, listen, if Vx is 0, then what will be this value?
0, sir.
Yeah, because I bring any children, he can also, this Vx is 0 means the whole thing is 0. If whole thing, current source 0, 0 ampere current source means what? This current source is deactivated. What does it mean? This current source will be open or it will be short to make it 0. Current source deactivate. Deactivate current source means what? Current source is open or
Short,
short?
sir. Short.
Your
Oh,
brain
open, sir.
shorted.
Open, sir. Open, sir.
Your brain shorted.
Open, sir. Open, sir.
Every children should understand it. Everybody understand what is going on. All of you are silent. You understand what I did?
Yes, sir.
Yes,
Okay,
sir.
good.
Yes,
If it
sir.
is open, then this will be our circuit. When we are going to short the AB terminal, then the middle term will go away because Vx is 0. If the Vx is 0, that means the middle term is out. And if the middle term out, then this is our final circuit. And now it is very simple and easy. It's a one loop circuit and you can easily find the current here. What is the current? And what will be this? This is only one current flow, which is I short circuit current. And I short circuit, any children, how to do? It is the, what law is a KVL, and you can find it. So, or I don't need to write KVL. Everybody should understand what is this. So you can easily find what is the IN. IN will be straight away. What is that? IN will be straight away. Short circuit current. Can you tell me what is I short circuit current will be? The voltage 4 divided by 2 and 3. 2 plus 3. K. That's
So
it.
0.8.
Yes, sir. Good. Excellent. Beautiful. So you are getting 0.8. 0.8 what? As a
Ampere.
kilo. It's a kilo, milliampere.
Milliampere, milliampere.
Right. So this is what, if you multiply with 10 to the power minus 3, if you write as an ampere, write 10 to the minus 3, then you can say it's an ampere. Otherwise, if you say the 0.8 is a milliampere. Okay, so whatever you get is this thing. So this is what you have to substitute. This is a volt. And if you want to put ampere, is better. So you put ampere here, 0.8 into 10 to the power minus 3 ampere. So volt divided by ampere is giving you the ohm directly. So what is that? What is the answer? Come on, Dam. Is it 10 into 10 to the power 3 ohm? Or you can say what? 10 kilo ohm, right?
Yes, sir.
Okay. So your Thevenin resistance, this is your Thevenin resistance. So Thevenin resistance is what? 10K. Tarannum, you got it?
Yes, sir.
Good. Now you see, this is what we have found. The value of R Thevenin is 10K. Full stop. Now you got the two answer, R Thevenin and E Thevenin. This is our first job in this problem. And next question is what? Next question is find the maximum power. Now what is the maximum power? Now go for the maximum power equation, and anybody can tell me the maximum power equation or forgot it already.
No, sir.
Yeah, what is that? Equal to?
ETH square divided by 4 RTIs.
Beauty. Excellent. Beautiful. Now tell me what is the answer? Pmax equal to what? E Thevenin is what? 8
Sir,
square.
8.
And 4 into R Thevenin is 10K. Remember 10K. Now 10K. Now it is a volt square. So 10K. So what is the answer now coming there? If you do the calculation, what is the value?
Sir, 1.6 milliwatt.
1.6 milliwatt. If it is the answer all of you get, that's excellent. Okay, so this is how you can solve the dependent source problem. So it is nothing, absolutely what you did in the last class. If it is dependent source, you have to follow the dependent source solution for the Thevenin theorem. At last class, I have shown you how to solve the Thevenin theorem using dependent source, and you solve it fast. After solving, then you can do rest of the thing. Now the question can tell you, hey, you find what is the power. Like I'm talking about the question number, like last time we say A, B, C, D, like that question A, you find If RL is 2K, then what is the P2K? You follow the formula. 8 divided by, what is the formula? 8 divided by RS. RS is your 10 plus 2K, then whole square into 2K equal just, you can calculate it. And then it can be a question coming here that, okay, if it is 20 milliwatt, question number C, B or C is equal to the 20 P power equal to 20 kilowatt, 20 milliwatt, find the value of RL equal to what? By connecting a RL over here. I'm talking about, this is RL you're going to put. This is the additional thing. And question number D said, okay, plot the power, PL versus RL. Okay, PRL versus RL. Then you can plot all these things. Those are the power, maximum power theorem question. So what happened here in question number 3? In question number example 3, we have seen that dependent source Thevenin solution as well as maximum power transfer combined together, and you have to find the answer. This is the way you can have one full question. Now, you all understand what I'm talking?
Yes, sir.
Yes, sir.
Right. Now, look, if you go and see, I know you are thinking, oh, Doc, what sir is talking about. Now, I just tell you, today's lecture is lecture 13. If you go to lecture 13 and so the practice problem here, and you go to the practice problem now, and if you open the practice problem now, you see every question got a two-part, part A and part B. Now this part B is added now, and you can see earlier we have given part A. Now part B is the maximum power theorem problem. So on the same Thevenin equivalent, you have to draw first in part A, and in part B, you do the maximum power theorem problem. And then you go for another one, if for example, okay, then what you can see here, also same, you can see, okay, if I can go for these two, you can see this is part A. This is part A is a Thevenin, and this is, okay, this is also maximum together. It is given together. Maximum power and Thevenin is together in part A. And here also you can see part A Thevenin's theorem. And if you go for part B, then you can see the, I hope that this will be the thing happen. Yep. If you go with this, you can see part B of the previous problem gives you maximum power theorem problem as a part B for the previous question. And you go for question number 5, and the question number A said maximum power Thevenin equivalent, and part B said maximum power dissipation thing. So all the problems are here in this exercise or practice problem are combining together the Thevenin's theorem and maximum power theorem. It can be a dependent source. This is all independent source, and you can see the dependent source problem also. Same type of question I'll give you. Now you are completely able to solve the assignment 2 problem, and assignment 1 problem you can solve for the Thevenin's theorem, Norton theorem, maximum power. And assignment 2, I think I told Jia to send an email to me to upload the assignment 2, right?
Yes, sir.
Yeah.
Yes,
Send it to me, I'll upload it, and then you can start solving the problems, whatever I cover, you can carry on so that it will not be a hectic for you to submit the assignment 3. I think that's all about the today's class about this maximum power theory and the end. Now, anybody got any question can ask me, otherwise we are going to close it down. Thank you very, very much for you to stay with me. I have another class at 12:13, 15, but still I am finishing it because the video lecture will be easy for you to understand in one shot. Okay, thank you very much for staying. Anybody got any question, or we are going to close the thing? Any question, anybody? Or okay? No question? Jihad, any question?
No, sir. Up to this
Okay,
is all right.
good. Akib?
Alhamdulillah.
Okay, fine. Muntasir?
No
problem.
questions, sir.
Good. Tarannum?
Yes, sir, it's fine.
Okay, everybody is fine. Then I'm going to shut it down for today. Thank you very much. Assalamu alaikum.
Thank you, sir.